So, so what we ended up with, I don't think I need this. For some reason my microphone wasn't working. So I had to shut it down and just restart it. Everything technology is not working today. Okay, so we ended up with these three equations and these three unknowns. So what we did the other day was we do the same thing. You can solve for A. So A is equal to 2 minus B. And then you could solve for C. C is equal to 4 minus 3B. And then you substitute those in the third equation. So you get 9 times A, which is 2 minus B, plus 3 times C. C is 4 minus 3B. And then you multiply everything out. So you get 18 minus 9B plus 12 minus 9B. So if you combine these two terms, you'll get 30, and then you'll subtract from both sides, so you get negative 37 is equal to negative 18B, or B is equal to 37 over 18. And yeah, then you can substitute back in and get A. So A is equal to 2 minus 37 over 18, and 2 is 36 eighteenths. So we get negative 1/18. And then we'll get C is equal to 4 minus 3 times B, B 37 over 18. So that's the same as 4 minus 37 over 6. This looks awful familiar. Oh, we did do it yesterday. Okay. Yeah, I'm like, we've done this before. Why don't you guys tell me that you... That's for Maya's benefit. Yeah. Okay, we already did that one. I'm like, those fractions seem awful familiar. Okay, let's go to the next one, whatever that one was. Oh, yeah. Okay, the next one, that's right. Okay, so the next one is... we have x squared minus 4x plus 7 divided by x minus 2 times x squared plus 6x plus 19 or 15. So even though this, so the difference in this case is we have a more complex term, and again this cannot be factored. You end up with two complex roots. So you're still going to break it up into two parts, which is going to be a over x minus 2 plus bx plus c divided by x squared plus 6x plus 15. And you still cross multiply. So if we do that, we'll get the numerator on the left-hand side is going to be equal to a times x squared plus 6x plus 15 plus x minus 2 times bx plus c. So it's really not that much more complicated than the last one. You'll multiply these terms out. You'll group the terms that involve x squared. You group terms that involve x, and group the terms that involve the constants and match them up with the coefficients on either side. So I'm going to let you do that one. Really the only difference is we've got one additional, we're going to have an ax, 6ax from here, and we'll have a negative 2bx from here, and we'll have a cx from there. So there'll be three parts to the equation that involves the x variable. So that may make it harder to solve the three equations, but let's come up with the three equations first, and then we'll talk about how we would do that. We might end up just using matrices and inverse matrices. We're definitely going to use that on the last problem. coffee out here. I need a cup of coffee after that craziness of the beginning of the day. Yeah, unfortunately, I'm not going to be able to come to the play. I would normally come to it, but my grandchildren are in this weekend, and I don't really take them. Yeah, I don't think they'd appreciate it. The 1-year-old, not going to think too much of it. So, even the 3-year-old, I'm not going to. I took my trumpet up with me to play when I was on my spring break, just to practice a little bit. But also, I thought, oh, the grandkids are like, that was a disaster. I played it for the twins, and they're just bouncing off the wall, getting all silly and everything. It was just not very rewarding. I have to bring in my music. Got some new music. It is hard. It's a jazz piece by Count Basie called Hay Burner. And it's, yeah, they say we can do it. I can possibly see us doing it, but man, it looks, sight reading it was a disaster. A lot of the guys have played it before. It's kind of a standard jazz or big band staple. Okay, so there we go. That's what I got. Hopefully, let me know if you didn't get that. So we set the coefficient in the x squared term here, wherever it is 1. So that equals a plus b. The coefficient -4 is equal to 6a minus 2b plus c. And the coefficient 7 is equal to 15a minus 2c. So if we tried to use the previous approach, we can't really do that here because we'd end up with we'd still end up with an extra variable in there. Now the question is, can we substitute these into there? Which the answer is yes. Okay, so we can still use substitution here. So what we do is we want to get this all in terms of c. So no, we can't do that, can we? How about in terms of a? Can we do that? So if I solve this for b, yeah. So if I solve this for b and plug it in there, and I solve this one for c and plug it in there, that middle equation will be just a function of a, and then we can solve for a. And once we have a, then we can use this to solve for b and this to solve for c. So it's just a matter of we just have to choose a different equation to do the substitutions into. So we're going to do b is equal, oops, wrong letter here. Solve this for b. B equals 1 minus a. Solve this one for C. So C is going to be 15A minus 7 divided by 2. What I did there, you're like, how'd you do that? So what I did is I said, I'm going to move this to the other side. That'll become positive. Move this to the other side, it becomes negative. So I get 15A minus 7. And then since this becomes positive when I move it to the left-hand side, then I just divide by 2. So that's how I did that. So then you can plug them into the middle equation. So you'll get negative 4 equals 6A minus 2 times B, which is 1 minus A, plus C, which is 15A minus 7 divided by 2. So you can see now it's just a function of A. And what I would do is multiply every item by 2 just to get rid of this fraction and then solve it at that point. Don't try to solve it with fractions. It's better to always take, anytime you have, this is back to Algebra 1, but if you ever have an equation in one variable, which is what we have, and you have any fractions, it's best to get rid of the fractions first by multiplying by the appropriate term, and then just deal with whole numbers until you get to the last step when you divide by the coefficient in front of A. So you'll get negative 8 is equal to 12A minus 4 times 1 minus A plus 15A minus 7. And notice I just multiply this by 2. I don't multiply both things by 2 because then I'd be multiplying by 4. These are obvious what you do, but once you solve for A, then you can go back here and find B and find C. And then we'll figure out what to do with them. So there's usually one partial fraction on the test for Chapter 8, I think. Maybe 2. Probably just 1. No, there's 2, I think. There's one with distinct linear factors, and there's one with a linear factor and a quadratic factor. So you have to know how to do both ways. Okay. So anybody got 3 over 31 for A? Good, good. Okay, so then B is going to be 1 minus A. So you get 1 minus 3 over 31, which is going to be 28 over 31. So that's B. And then C is going to be equal to 15 times A minus 7 over 2. So 15 times 3 over 31 minus 7 divided by 2. So what do we get? We get 45 over 31 minus 7 over 2. And 7 is 20, well, yeah, 45 over 31 minus 7 times that is 240. 17. So it's going to be 217 over 31 over 2. Time to get my calculator out here. So 45 minus 217. So I get negative 172 over 31 divided by 2. 172 divided by 2 is 86. So I get negative 86 over 31. So that's C. That's not a very nice number, is it? Did anybody get that? No? Anybody get B right? Did I make a mistake? Did you get it right? You get? Okay. So the chances of us all both making mistakes is probably low. So we'll assume I'm right. So, the question is how did I know to divide this by 2 and not that by 2? And that's because I'm taking this and I'm dividing by that fraction. So I could take the reciprocal of this, and no, actually I'm taking this fraction dividing by that. So this would be 2 over 1. So take the reciprocal, it'd be 1 over 2. So I'd have 1 over 2. So I know to divide 172 by 2, which is what 86 is. Okay, so those are the coefficients. So if we go back now to our original expression, all the way back here, wherever it was. Oh, here it is. What we can do is we can rewrite the integral. If we do the integral now, so if we wanted to do the integral of this original expression, it's going to be the same as the integral. It's going to be a times the integral of 1 over x minus 2 plus b. Now the next part's more difficult, so it's not quite the same as the last time. So let's not go too far here. So we'll have bx plus c over x squared plus 6x plus 15 dx. So let's go ahead and put them in there. So we have 3 over 31 times the integral of 1 over x minus 2 dx, forgot the dx here, plus the integral of b was 28 over 31 x, and c was negative 86 over 31, all divided by x squared plus 6x plus 15 dx. So obviously the first part's easy. It's going to be 3/31, the natural log of the absolute value of x minus 2. The problem we have here is that because we have this linear term, the derivative of this denominator is not just going to be 2x dx like it's been in, if we separated the x part before, we didn't have this. So the derivative of 15 was 0 and the derivative of x squared was 2x, so it matched up perfectly. But in this case it doesn't. So what we're going to do is we are going to go back to what we did in chapter 5. So let's just look at the second integral. What I'm going to do is I'm going to factor out the denominator of the fraction. So that'll be 28x minus 86 divided by x squared plus 6x plus 15 dx. And what we said was that we want the derivative of the denominator to be some, this has to be some constant times the derivative of the denominator plus another term that's another constant. So we did that. You'll see this. What we said was we let 28x minus 86, and I'm going to use a and b. It's not the same a and b's, but it's going to be a times 2x plus 6 plus b. because this part is the derivative of the denominator here. So that's the part I'm going to group to use. This is the u substitution, where this is u and du is this. And then the remaining part will be a constant. So I'll have a constant over this, which I can use the arctangent to do that part. So we need to figure out what those two numbers are. So it's kind of like we just did previously for partial fractions. You multiply out both sides. So you get 28x minus 86 is equal to 2ax plus 6a plus b. And you set the x parts equal to each other. So you get 28 is equal to 2a, or a is equal to 14. And the constant part is negative 86 is equal to 6a plus b, but I just figured out what a is. It's 14. So I'll have negative 86 is equal to 84 plus b, or b is equal to negative 170. So if you subtract 84 from negative 86, you get negative 180. Okay. So what that means now is I can go back here and I can, so I factored out the fraction, and then I have times the integral of a, which is 14, times 2x plus 6 divided by x squared plus 6x plus 15. And then I have the second term, which is going to be negative 1 over 31 times the integral of 170 divided by x squared plus 6x plus 15 dx. So in this case, because of the way I chose to define a, this is dx, 2x plus 6 dx is du, with this being u. So if I let this be u, this is du. So when I integrate the integral of d over u, I'll get the natural log of the absolute value of u. So this result is going to be 14/31 times the natural log of the absolute value of x squared plus 6x plus 15. Okay, we'll write that down in a second. This one, you have to complete the square and get this into u squared minus, or u squared plus a squared, so I can use the integral for the arctangent. So we'll do that separately here as well. Now that I've got, so what we're going to do is we're going to take the denominator of the last term, x squared plus 6x plus 15, and we'll take the coefficient in front of x, we'll divide by 2, we'll square it, which is 9. So add 9, subtract 9, and you'll get x plus 3 quantity squared minus or plus 6. So this part here, I'm gonna go ahead and erase this. Sorry. It can be replaced with x plus 3 squared plus 6. So for this one, u is equal to x plus 3, and a is equal to the square root of 6. So now it's in the form of u squared plus a squared. And we know from previously that, you know, the integral of 1 over a squared plus u squared is 1 over a times the arctangent of u over a. Okay, just like it was in the previous example. The only difference is that instead of just having x squared plus some constant, we have x plus 3 squared plus some constant. So here's the final answer. Now that we have all that information put together, so we get 3 over 31 times the natural log of the absolute value of x minus 2 plus 14 over 31, so that 14 is that number, times the natural log of the absolute value of x squared plus 6x plus 15 minus 170 over 31 times 1 over the square root of 6 times the arctangent of x plus 3 over the square root of 6 plus c. Okay, so there's the answer. So we had the same thing happen last time. When you had a linear factor and a quadratic factor, you end up with one term that's the natural log of the absolute value of the linear factor. You get a term that involves the natural log of the quadratic factor. And you get a term that involves the arctangent of the expression written so that the denominator is a perfect square, and you get u squared plus a squared. So there you go. That's it. Yes?
Would you be able to do it the same way if a, b, and c didn't have the same denominators?
You would have to find a common denominator. It'd be the best thing to do. I think most likely they do have the same denominator just because of the way we calculate them. So that's usually what happens. So you can factor out the denominator, make it simple. But if you didn't, you would just make them so they do have a common denominator. Okay, so now for the crowning jewel of this whole thing. We're just going to look at it for a second here, and we'll work on it on Monday. So it's pretty much the same as what we just did here. Well, not really, because it's got a lot of stuff in there. Okay, so let's look at it. You're like, oh God, you're killing me. This might take us all period to do one problem. That's okay. We're getting lots of practice. So there's a couple of things this one is going to do for us. We've got one extra linear term. So the question is, how do you handle one extra linear term? We're going to be doing some interesting polynomial multiplication. So we'll talk about that as well. But just as the last thing to say today is this is going to be broken up into a over x plus 4 plus b over x minus 2 plus cx plus d divided by x squared plus 3x plus 8. So if you have additional linear terms, not surprisingly, you just add an additional term. The problem, you can't use cross multiplication here because you've got 3 terms. So what we're going to do is we'll take a times this times that plus b times this times that, and then this whole thing times that, which is going to be some fairly complicated polynomial multiplication. So we'll talk about how you do that. Ultimately, you'll come up with 4 equations and 4 unknowns. And we're not going to want to use substitution. We're going to want to use our calculator to use matrices to solve it. So you guys in physics, we've already done that. We'll get more practice at doing that. So we'll use our calculators to find the 4 coefficients once we come up with the 4 equations. So again, the procedure is exactly the same. It's just more complicated polynomial multiplication and more equations and more unknowns. But as far as the basic procedure, it doesn't really change any. Okay, so we'll do that starting on Monday. We'll finish it